Okay, we're back here with part 4 of our hazardous materials event lecture. Let me share the screen with you again. I'm going to get real good at this real fast. Let's pull out the little quirks. Okay, part 4. We are going to put together an incident action plan, and you better know this first objective. We're going to explain 3 strategic objectives, and then we're going to get into some 3 tactical objectives. Hopefully our bottom line is to try to make this problem go away. So we need to develop a incident action plan, and it's based on all the assessments that we've done. We've gone out and we've gathered all our information, and we've analyzed it, we've looked at it, what's good, what's bad, what's going to hurt us, what's not, how can we proceed. Every hazardous material incident must have a written IEP. This is what gets a lot of departments in trouble. You need to actually sit down, and you have the time to do it, is to write this out. If you don't, and people get hurt, you're in trouble. So your IEP, incident action plan, consists of strategy and tactics. Okay, some of the things we look at. We all know what our objectives are, and I'm not even going to tell you, because you better know. What our goals are, how are we going to fulfill those objectives, and we need to get in and do we have to rescue people? Do we have to protect them? Public protective actions. Do we have to contain the spill, confine it, the spill or leak, fire, make it go away? And then the bottom line, the end product is, how do we recover? How do we put the property back the way it was before this incident occurred? Our objectives, our tactical objectives are very specific, assigned to responding units. We may give someone, the hazmat team is involved in controlling the site, okay, or controlling the product. Okay, now our tactical, there's 3 modes we're going to go into when we go to our tactical objectives. We can either go offensive and shut the product down, patch the hole, fix the leak. We can go defensive and just make sure it doesn't blow the town to smithereens, or in some cases we may not even intervene and let this thing go and see where it develops. Good example of that was a pesticide store up in Maine that the fire chief let burn to the ground because if putting water on it would have caused too much environmental runoff. 3 situations we look at that are pretty special to us is when we look at assessment of pressurized bulk transports. Remember, we're transporting something across the country, whether it's on the rail or over the highway, in a pressurized vessel. Okay, it's greater than our atmospheric pressure. So if something goes bad and there's a hole or a leak or a breach, this thing's going to come out under pressure, and we need to know what that's going to do. We need to understand also what happens when chemicals or petroleum products are released underground. Okay, if we spill a tanker full of gasoline or oil on the ground, it seeps into our ground. Will it get into our groundwater and contaminate it? And a lot of places, not so much out here in Arizona, but we have a pretty extensive sewer collection system in our major cities where this can become a nightmare. Can you imagine in New York City with their subway system having a gasoline truck pouring flammable gasoline down into the subway system? So the damage assessment of pressurized containers includes looking at where the container is cracked. We're going to look at dense rail burns. Let's say that rail car derails or the tanker derails, and it starts getting burns and starts stressing out the tank shell. This is very common in a crash. Okay, and then we want to look at where that occurred. You know, what part of the metal was occurred. There's a lot of, if you look at a corrosive tanker, it carries a lot of welded areas, a very protected area that's designed to protect the tank in a crash. Okay, and these are just different things we want to look at. These are some pictures of the cracks. These cracks can very easily get larger, and is where we call runaway cracking. If there's a lot of pressure behind it, pushing on it, now we've weakened the steel. Okay, all of these are results of a crash. Remember, because a railroad is so powerful, the locomotive's pulling it, these rail cars may be dragged for a mile or two before they actually come to a rest. It takes a long time for a train to come to a stop. So if the derailment is midline of a 100-car train, that locomotive system is going to pull this car for quite a distance and do quite a bit of damage to it before it comes to a halt. Okay, when we look underground, we want to make sure what type of soil are we dealing with. One of the fortunate things out here in Arizona is we have very hard soil with caliche underneath, which is a clay-like substance, which kind of would hold our product in an area where we can probably contain it and remove the contamination. In some more gravel or loose soils, that product's going to go right into the ground and into the water table, depending on how deep our water table is. Okay, groundwater accounts for a majority of our drinking water, so it's very possible that the underground aquifer will get contaminated if there's a large enough and long enough breach. Okay, and you also got to understand that groundwater aquifers are underground rivers, and they actually flow. So they will flow to different areas and carry that contaminant. This is just another information pack. Okay, and then we're still looking at that. Okay, so another system we want to look at is our behavior of our spills once it gets into a sewer system. If we're out in the if we're in an urban environment, a lot of sewers. There's sanitary sewers which are usually sealed. They carry our human waste back and forth to the treatment plant. There's also sewers that are designed to collect rainwater. In areas that get a lot of rain, we have to channel that, or else we get flooding. So if it's channeling rainwater, it's moving downstream, it's moving with gravity, so the same thing happens if a liquid gets into that sewer. We had a problem with a leaking gas tank in New Britain where the underground tank leaked into the sewer system and was moving flammable gasoline throughout the sewer system because it's lighter than water, and it was floating, and we had a few explosions occur because of that. We've chased several chemical and liquid spills throughout the city's sewer system, so it's vital that a hazardous materials response team has mapping of sewer collection system. Where does it go? Where does it end up? You may have to bring in someone from the water department or public works that has an extensive knowledge of the sewer system. If you have some sort of computerized database, you can overlay your mapping right into your computer so you can follow it. Like I said before, there's two different types or three different types. Sanitary sewers, this is what transmits your waste. These sanitary sewers can be under pressure. There might be a pressure line if, let's say, we have to pump affluent upstream. So we need to pump it. And most sanitary sewers operate on gravity and are not sealed. So if a manhole cover would be breached, you might get a contaminant in there. The contaminant in your sewer system will play havoc with the biological degradation, how affluent and how sludge gets decomposed. So that also needs to be understood. So this is where your public works people play a role, in your hazmat response team. Okay, if this stuff gets into your sewer system and it's moving towards your treatment plant, it might be to your advantage to collect it before it gets into some of these other systems, or else it's going to contaminate the entire system. Other concerns we look for, fire, obviously. Is this thing going to burn? If it's a high vapor liquid, it's going to burn, it's going to blow out. Environmental concerns. This is probably one of my biggest issues when we have a hazmat spill. What are we doing to the environment? Are we dumping chemicals into a environmentally sensitive area, such as a collection agency, a swamp, vernal pool, small areas? There's a lot of our ecosystem that becomes affected. You saw the environmental effects of the oil leak in New Orleans and the Gulf of Mexico, where BP dumped hundreds of thousands of gallons of crude oil into the environment and the ocean. So, like I said, pre-planning with Public Works is critical. Knowing your sewer system, knowing your entry, knowing where water goes, groundwater goes when it leaves the city. If it gets into the sewer system, where does it ultimately dump out? Does it dump out into a riverbed? Does it dump out into a stream bed that needs to be protected? Whenever we knew exactly where our stormwater was going, so in times we were able to race to the outlet point and put some containment booms down that would pick that contaminant up as it left the scene and didn't go any farther. So this is a summary. We're at the tail end of this long, enduring chapter, but this is the most important one. So where are we? Where do we finish here? We need to understand the physical and chemical properties of our material. We need to know what it is. That's the information gathering process. The analysis process is where we assess how bad it is. What's it going to do to us? What's it going to do to our environment? We use detection devices to gather information. We use detection devices and modern technology to tell us how bad it is. We can do research. We can look it up in books. We can go to the computer. We can use computer modeling. We can ask experts in the field, how bad will this affect us? All this information comes to us so that we can sit down and write a detailed incident action plan that's going to address life safety, incident stabilization, environmental, and property conservation. So that's the end of this particular bad risk takers get buried. I like that one. Okay, effective risk evaluators go home. So we're in this job to be an evaluator. It takes time, and hopefully we can come out with a good outcome. So thank you very much. That's the end of this particular assignment.